So I'm here with Michela Taufer, who has been a friend and a colleague for a number of years. We have met in different places. We are here taking a little break from the International Conference on Parallel Processing, visiting the Natural History Museum here at the University of Utah. So, Michela, this video is for students that are, in their undergrads and contemplating doing systems work and research. So, the first question for you is how does the thinking is different for a systems researcher in comparison with other areas of computing science?
Well, hi Nelson, thank you for inviting me to join this discussion. Well, when we think about computer systems, we tend to think about big boxes, something that generates science. But these big boxes have a core inside and components that are very powerful, allow us to enable scientific discovery. Now, if we look at what is a computer system, there is not really a big definition that is valid for everyone. For some of us, a computer system is a big supercomputer. For others, is our laptop. Nowadays, so powerful. But the part that is more fascinating is that computer system can be also sensors that are sending messages through Wi-Fi or other medias, and then collect data in a data center. So there is such a variety of definition of computer system. That is very exciting because there is a computer system for any of us. And so if you are passionate about, for example, weather and climate, computer systems are very different from if you are more interested in car simulation, velocity, aerodynamic. So we have to think about computer system as with an open mind, but at the end of the day is a combination of tools, and we need to glue them together through software and interfaces to make them available to scientists.
So, Michela, you are quite well known for the work that you have done on applications for high-performance computing. What excites most you about your work on the applications area?
The reaction of the scientists when they see what we can enable them to do. You know, there is an episode that I'm in my mind and I think about. So I was working with the GPU when the GPU were at the beginning, 2007, 2008, and we moved the code for simulation of large membrane on GPU. And so just there, we were able to simulate large membrane of our body that were not possible before. But then, with a colleague of mine, Sandeep Patel at the University of Delaware, we started working with small molecule peptide that were scooping the membrane and then were penetrating. It's the process that happened in our cells. And he knew that theoretically, but he has never seen it. And we made that possible. And I saw him really smiling. And it was great to see the reaction of my colleague who have seen something that he saw in the book mathematically. And now visually with the AI performance computing and visualization was reality. So that is a small example. And I think that many of us have these experiences, and many of us should make this as a mission, creating this feeling of achievement in our colleagues.
So that's a really nice story. Thank you for sharing that. And I think that's one of the things that's about, right, is building systems to enable people to do good science. Right?
Yes, indeed. And there is a system for everyone. It's an application that is our passion for everyone. So join the system community.
Thank you very much for this.